All right, let's dive into something that's running silently behind almost everything you do online: database security. Today, we're going to pull back the curtain and see exactly how your digital treasure is kept under lock and key. So, let me just start with a quick question for you. Think about the last TV show you binge watched and, say, your bank account balance. I know, they seem like they're from two totally different worlds, right? But they share a deep, fundamental secret. And here it is. They are both incredibly valuable pieces of treasure, locked away inside a massive digital fortress. And just like any real-world fortress with treasure, this one is under a constant, relentless siege from people who want to get their hands on what's inside. Okay, so if we're going to protect this fortress, we first have to understand what protection even means. What are we actually trying to do here? Well, it really all comes down to a few core goals. You know, in the security world, pretty much everything rests on these three pillars. You'll hear them called the CIA triad. Confidentiality is simple. It's a secret and only the right people get to see it. Integrity means that secret can't be messed with or changed by someone who shouldn't. And availability? Well, that just means your data is actually there for you when you need to access it. Get these three right, and you've got a solid foundation. Now, what's really wild is just how many different ways this fortress can be attacked. You've got the high-tech stuff, like hackers using SQL injections. You've also got low-tech threats, like someone literally walking in and stealing a physical server. And maybe the scariest one of all, the threat that's already inside the walls. This is exactly why one big wall is never enough. You need layers upon layers of defense. So let's talk about that first layer, the main gate. Before anyone even gets a whiff of the treasure, we have to be incredibly strict about who we even let inside the fortress walls in the first place. And getting through that gate is always a two-step dance. The first step is authentication. That's the guard at the gate looking at you and asking, "Who are you?" They're checking your ID, your password, your fingerprint, whatever it is. Then, once they know who you are, comes step 2, authorization. This is the guard saying, "Okay, Bob, you can come in, but you're only allowed to go to the kitchen. The throne room is off limits." One confirms your identity, the other defines your permissions. And we have to remember, this fortress isn't just some abstract idea in the cloud. It's a real place. The servers holding all this data are in physical rooms. That's why physical security is absolutely crucial. We're talking locked rooms, security cameras, even systems to protect against things like fires. You simply can't have digital security if the physical location isn't secure. So, what happens if an attacker is clever enough to get past the gates and the guards? Well, our next layer of defense is all about protecting the treasure itself, making it completely useless to a thief, even if they manage to snatch it. Okay, so check this out. Imagine this as a piece of treasure, a user's salary, just sitting there in plain, readable text. If a thief gets their hands on this, well, game over. The secret is out, it's totally exposed. But now, watch what happens. We apply encryption, and that same simple salary figure becomes, well, this unreadable jumble of characters. Now, even if the thief steals the file, all they have is gibberish. They've got the box, but they have no key. That's the real power of encryption. Here's another really cool trick. Think of a database view as kind of a magic window. Instead of letting someone wander around the whole treasure room, you give them a special window that only lets them see the one specific pile of coins they're allowed to. All the gold bars and jewels right next to it, completely invisible to them. It's all about giving people exactly the data they need and absolutely nothing more. A truly secure fortress doesn't just sit around and wait to be attacked. No, it has watchtowers, scouts, spies. It's constantly on the lookout for any sign of trouble. It's all about being proactive. And this is the logbook from the guards in that watchtower. Every single action, every time someone enters the castle, every time a file is opened, every tiny piece of data that gets changed, it all gets written down. So if something goes wrong, this logbook is the very first place you look to piece together what happened, who did it, and when. Now, let's look at one of the most common ways attackers try to get in. Imagine they're not trying to smash the gates down. Instead, they're trying to trick the guards into opening the gates for them by disguising malicious commands to look like innocent requests. This classic attack is known as SQL Injection. So, how do our guards get wise to this? They're trained to never, ever trust a request at face value. They use special techniques that very carefully separate the instructions from the data. This makes sure that a malicious command trying to disguise itself as harmless data just can't sneak through and wreak havoc. But even the most impenetrable fortress has to prepare for the unthinkable. What if the walls are breached? What if there's a fire or a massive system failure? You absolutely have to have a doomsday plan ready to go.
And that's where backups come in. Perfect copies of your treasure stashed away in a safe place. But as this chart shows, not all backups are created equal. You've got a full backup, which is huge and slow, but super easy to restore. And on the other end of the spectrum, you have incremental backups, which are tiny and fast, but putting them back together is a lot more complicated. It's that classic trade-off between speed, size, and simplicity.
And this shows you exactly why restoring that incremental backup is more of a puzzle. You can't just grab the latest file. No, you have to start with the last big, full backup, and then you have to layer every single little change on top of it, one by one, in the perfect order, to get back to where you were. So when that worst-case scenario does happen, it's not chaos. There's a formal plan, a playbook. Step 1, figure out what happened. Step 2, contain the damage, stop the bleeding, fast. Step 3, restore everything from those safe backups. And finally, maybe most importantly, you document everything you learned so you can make the fortress even stronger and prevent it from ever happening again. So as you can see, database security isn't just one magic bullet. It's a deep, multi-layered defense. It's the guards at the gate, the locks on the vaults, the scouts on the walls, and the emergency escape plan, all working in concert to protect that digital treasure. And that leaves us with one last kind of unsettling thought. We've built all these incredible defenses to stop attackers from the outside, but what if the single biggest threat isn't a hacker 1,000 miles away, but a trusted person with the keys who is already inside the walls? That's the question that keeps security experts up at night.